Hi everyone, and welcome to this webinar, Recycling Unpacked, a guide to material recovery from electronics. My name is Louise Eriksson, and I'm Principal Consultant and Team Lead in Stena Circular Consulting. I'm here with my colleagues Ricardo and Alex, and we will introduce ourselves a little bit further soon. But first, just for those of you who don't know Stena Recycling and Stena Circular Consulting, I can very briefly mention that Stena Recycling is the largest recycler in the Nordics, turning 6 million tons of waste into new raw material every year. And Stena Circular Consulting, we are the consultancy arm of Stena Recycling, and we enable circular business solutions by providing insights, advice, and recommendations connected to circular product design, to waste management optimization, and also to circular strategy and circular business models. And today we will talk about one of our core knowledge areas, design for recycling. And in this webinar, we will use electronic products as example, mainly because it's one of the more, let's say, straightforward cases when it comes to design for recycling. But we will explain that more as we go. So moving on to us, again, here we are. So I'm Louise Eriksson, as I said, Principal Consultant and Team Lead in Circular Consulting. And I've been working here in Stena Recycling and Stena Circular Consulting for 6 years now. And before I joined Stena, I worked for around 10 years in IKEA, different companies and different roles, but mainly within product development and production development. And over to you, Ricardo.
Yes, hi everyone. My name is Ricardo Paccaloni and I'm a project lead in the team. I've been in a company now for 4 years and my background is within the design field, design development and sustainable design.
Alex Gofasco, I'm an all-rounder generalist and now project lead at Stena Circular Consulting.
We'll take a look at the agenda for the webinar, and today we will go through the following sections. We'll do an introduction, or that's actually what we're doing right now. It will soon end. Then we'll go into what is recycling and then design for recycling. And at the end, we will share some insights from a case that we did together with Fagerhult. And at the end, as Alex said, there will be time for questions. I'm thinking that's all for the introduction, and we can move on to the more exciting part, perhaps. And the starting point is this. Most materials are theoretically recyclable, but far from all products get fully recycled in practice. Now, why is that? And yes, that is what we're going to find out. And to understand which products that are, and also materials that are recyclable in reality, we need to understand the underlying parameters that decides recyclability. They are 4, as you can see in this slide. And the first one is regulation. We need to understand what regulations that are affecting the product at its end of life. Is there, for example, an extended producer responsibility for the product? We also need to understand what the recycling system that the product belongs to looks like. So what actors are involved, where geographically will it be recycled, and so on. Thirdly, we need to understand what recycling processes that are used for recycling this product and what materials that are recovered in those processes, the recycling processes. Lastly, we need to understand what design choices that have been made for the product. So what materials are used and how are they put together? So we will build the presentation today around those 4 parameters and explain how they're all affecting recyclability of products. But let's just start with a short definition of recycling. So what is it really, and how is it connected to circular economy and sustainability? Well, recycling is very briefly the process of converting waste materials into valuable products. And recycling is part of a larger context, of course. So because if we want to create a long-term sustainable economy and way of doing business, we need to treat the materials, such as metals and plastics, differently compared to how we do it today. We need to get to a circular economy instead of the current linear economy where materials are mined, used, and thrown away. So instead, we need to prolong the life of the products we have created already for as long as possible through repairing and reusing them. And after that, we need to renovate and remake them and also to harvest the components that they contain to give them a longer life. And that we can do through refurbishment and remanufacturing. And eventually, at the very end, we need to recycle all the used materials to be able to create new materials from them. So recycling is the outer circle in the circular economy. Now going back to the 4 parameters, the first one, as you might remember, is regulation. And one of the reasons for choosing electronics recycling as example today is that there is a fairly clear situation for electronic products in terms of legislation. So EU policy has shaped and will continue to shape the national end-of-life systems for electrical and electronic products. And at the core, as you can see to the left in this picture, we have the Waste from Electrical and Electronic Equipment Directive, also called the WEEE Directive, and also the Waste Framework Directive. And they together require a dedicated collection and treatment of electrical and electronic equipment, and they set targets for collection rates and recycling rates for the products included. They are in turn complemented with, for example, the Batteries Regulation, the Eco Design Regulation, and the Critical Raw Materials Act, and more. And together, they have formed the end-of-life system, which, as you might remember, was our second parameter for the product categories included in electronic products. And it looks very simplified, like the picture on the right-hand side. So when a user no longer needs their products, they can hand it in either to municipal collection, retail collection, or for reuse. And if the product is still fully functional and has a second-hand value, it is being sold on a second-hand market. But if the product is outworn or has lost its value, it will instead be sent to a recycler. And now we will look into that last box a bit closer, the recycler. And it is so that in that box, we have quite a lot of complexity hidden that we can look at together. So the overall steps within the recycling box are collection, reshaping, sorting, processing, and refining. And dependent on which product category or material category we are looking at, this is done differently. Different actors might be involved, and they can also take different roles. For example, for some of the plastic types that are included in electronic products, Stena Recycling takes care of the full process here. So from collection all the way to recycled plastic pellets. Whereas for a packaging material as paper, Stena Recycling might only do the collection and the reshaping, which in the case of paper packaging actually means baling for optimized transport, you could say. And then other actors are taking care of the rest of the chain. One thing that usually is the same though for all product and material types is the shift in geography levels, you could say, along the process. So the collection is naturally done on a local level. The reshaping and sorting is done on a regional level. Here it's important to gather large enough volumes to get a viable business case for the processes that are used. And the final steps, they are done with a global market in mind. So either the materials are being processed and refined elsewhere on the globe, or the materials that are coming out of that process are sold as a commodity on a global market, you could say. The business logic for a recycler is different depending on the value of the collected products or materials. So some materials have high value, like metals. Then the recycler actually pays to receive the material. Then they process the material or the products further to be able to sell them at a higher price at the other end. Some materials are hazardous and they need to be taken care of even if they don't have a high value. And then that is, of course, stated in the legislation. And in those cases, the recycler instead gets paid to collect and handle the material And after processing, they have made it the materials non-hazardous instead. But if we look at the non-hazardous materials, the ones that we want to recycle and circulate, recyclability is thereby, if you look at this explanation and the process here, you can understand that the recyclability is actually steered by both the value of the material, but also ultimately of the global demand for the recycled version of each specific material type. This means that if we have product developers or product owners in the audience today, you might understand then that you can actually contribute to making more products recyclable or more materials recyclable by designing your own products from recycled material. So because when we design and build products with recycled material, we create a demand for recycled material. And it goes both ways. So when we design and build products that are recyclable, we create a supply of recycled materials. And that's when we get a well-functioning market for recycled material. So moving on to the third parameter, the recycling processes. Electronic products represent a combination of what I described above. So they both include hazardous waste and valuable materials. But it differs a lot from product to product. And the recycling processes of waste electrical and electronic equipment in EU, therefore aims to both remove the harmful substances while at the same time enabling circulation of the valuable materials. And in short, the process looks like this, what you can see on the screen. After collection, the products are transported to a recycling facility that is specialized in electronics recycling. And the products are sent there in huge volumes, often in mixed product flows, and are many times, not always, but many times treated quite roughly, actually. And as I said earlier, economies of scale is still crucial to make this part of the recycling system financially viable. The first step is a manual step that you can see to the left. It is called first treatment. And there, hazardous waste such as capacitors or oil or problematic materials from a process point of view, such as wood, are removed. Sometimes also PCBs, printed circuit boards, are removed in that step, but not in the processes that we have in Stena Recycling, because we take them out later on in the process. But then after the first treatment, the products are divided into two streams, one for reuse and one for recycling. And reuse is, of course, for functional products that have a second-hand value, such as computers or computer components, and also mobile phones and a few more others. And these products are cleaned, restored, and treated to be sold and used again. The rest of the products, they continue for recycling. And the PMR, precious metal recycling process, does not include any manual steps. So instead it consists of a series of roughly 30 steps using different technologies to separate and identify the materials that are there from each other, so to speak. So it's, for example, a shredder. The first step is a shredder to take down the products and the materials into smaller pieces of materials, and then magnets, eddy current magnets, sieves and sink and float pads, etc., are separating these materials into different fractions. And the materials that are taken out for recycling are, for example, steel, stainless steel, aluminum, copper, circuit boards. That's not a material, but that's, as I said earlier, that's where we take out printed circuit boards in Stena Recycling. And also plastics, but actually only 4 plastic types. It's PP, PE, PS, and ABS. Lastly, what has not been able to be separated or identified in the process goes to either incineration, used for district heating, if it's possible to burn, or to landfill, if it's inert. And this process is, of course, constantly under development, but this is the current situation in Stena Recycling and among most recyclers in Europe and the EU. So moving on now to design and the design aspect, our last parameter. So depending on how the recycling process, our third parameter, is built up, which technologies that are used and what materials that are recovered in it, the product design of your products can either support or hinder the material identification and separation. So the previous slide showed, of course, the electronics recycling process, as you know. So the prerequisites that we're talking about here today are valid for electronic products. As an example, we can compare it with a PET bottle, a PET bottle. And as you know, PET bottles are, at least in Sweden, treated in a system where only PET bottles are treated, a closed system, very efficient with a deposit connected to it. And in that system, PET is the plastic type that is being recycled. So PET plastics in a PET bottle is, of course, fully recyclable in practice. But if you use PET for your electronic products, that is not an wise choice, since PET is not one of the 4 plastic types that are being recycled in the electronics recycling process. So in there, the PET is a non-recyclable plastic. So that's important to understand. But going back now to the electronic products, to the right in this picture, you can see the 3 most common design changes or design actions that you can take that we have seen in our design for recycling projects that would improve recyclability of electronic products. And they are, starting from the left, to use recyclable materials wherever possible. And then we talk about recyclable in practice, of course. And when it comes to the plastic types, go for the big volume plastics as often as you can. Also for the big volume metals, same thing there. The second part is about the joining methods. So here we encourage you to use separable joining methods. This means to avoid co-molding or gluing different materials together. And the reason for that is that in the process, co-molded or glued parts are not separating, and therefore it's both difficult to identify what type of material it actually is in that piece of material, and also if it gets identified as one of the, for example, plastic types there that are used, the other plastic type will pollute the stream and create a lower quality of the material. At the bottom there in the middle, you can see a picture of screws attached to plastic, and that's another example that we see a lot. So screws or plastic parts that are jointed together by screws, they are not separated from the screw in the process, and the screw is removed from the rest of the materials with the magnet, and then the plastic is following the screw. So then we lose the plastic and the possibility of recycling it. To the right, you have the third action, and that is to design for manual disassembly for the components that could be relevant to disassemble manually. So for example, as I said earlier, the ones that are relevant for reuse, but also the ones that contain hazardous waste or hazardous materials. And to do this, you need to incorporate a smart product structure into your design, and thereby enhance the likelihood of capturing those valuable components or hazardous components. So this is an example, a few examples. You could, of course, get more into the details, but we'll stop here. This is the explanation of how the different parameters are affecting the recyclability and eventually from a design perspective. So as we've seen now, recycling in practice is dependent on those 4 parameters, and losses can occur in all stages. And the major loss is actually in the system parameter. So more specifically in collection. An estimate from EU shows that within the union, only 54% of all WEEE is collected. The rest ends up in metal scrap, the waste bin, or export, illegal or legal. Or there's also a part here that says unknown, and we think that might be hibernation to a large extent. That means that people are keeping their products at home even if they don't use it in the garage or a drawer or so. And here we encourage you all to focus on what we can impact. So inform your customers about how to dispose of the product. That's one thing to start with. And also start to design your products for recycling and from recycled material. That's another good first step. To summarize, to maximize the chances for high recyclability, there are several steps to take when designing your product. So firstly, you can investigate the legislative landscape and the end-of-life system. And in that way, you will be able to maximize the likelihood of collection and also future legislative compliance, of course. It's important to understand the recycling processes and corresponding material recovery to guide material choice in the design phase and thereby avoid losses in the recycling processes. Thirdly, adapt the product design to the end-of-life system and the recycling processes to improve material separation and thereby the quality of the recycled materials. And lastly, to the right, I'd like to again emphasize the importance of both designing for and from recycling to create the supply and the demand and get this well-functioning market in place. This might sound like a lot to keep in mind, and I know that product developers and product designers have a lot of other things to also keep in mind, but it might be good then to know that we can support with this. We have created a framework for assessing recyclability, and we support companies by doing these design for recycling assessments. In them, we visualize the recycling prerequisites for your specific products. We estimate the actual recycling rates, and we highlight both the barriers for recycling from a design point of view, for example, but also opportunities for improvement. And the pictures you can see in this slide, they explain the 4 steps that are taking place in those projects. So we start with a system mapping. We typically do a product teardown to fully understand the products. We do a quantitative and a qualitative analysis. And we will end this webinar now with showing an example from a company who did this with us. As I mentioned in the beginning, we did a design for recycling products together with Fagerhult. And I will hand over to you, Ricardo, to tell more about that.
Thanks, Louise. Again, we will share with you just a glimpse of the collaboration with Fagerhult AB, which is a part of the Fagerhult Group, a major international organization with several lighting brands in its portfolio. And from our perspective, without exaggerating too much, we see Fagerhult as an industry frontrunner when it comes to sustainability and circular design. The company focuses on 4 key areas when it comes to sustainability. In addition to develop energy efficient products with high lighting performance, they are also committed to implement circular solutions, pure materials, conscious production. When it comes to circular solution, is their goal to develop and implement circular business models, but also ensure that newly developed products can be repaired, refurbished, reused, or even recycled. And when it comes to material choices, they also aim to increase the use of recycled materials like aluminum, steel, or plastics. In line to this, Fagerhult wished to learn more about the end of life and recycling, so we teamed up to help them assess and improve their products' recyclability. So as part of this project, we analyzed 2 different luminaires and applied our team's design for recycling methodology that Louise was mentioning. And the products selected by Fagerhult were 2 of their best-selling products for the assessment to ensure a real impact from the learnings and possible developments. And these include an end-of-life analysis, mapping, as Louise mentioned. And as we heard, according to the WE directive, such products must be recycled properly. They fall into 2 different categories, each specific with specific collection and recycling targets. This classification also influences how they are taken care of at the end of life and the recycling phase. In fact, the larger product, due to its size, enters a different and more rough recycling process, which may result in higher material losses compared to the smaller product, which goes into the what we called the PMR process, precious metal recycling, from the start. So we conducted a product tear down to identify both challenges and design features that either facilitate or hinder proper recycling. And we organized a live disassembly together with Fagerhult team in our lab, where we have a setup for this type of live disassembly meetings, which also allows for real-time discussion. And what's always good to have is that taking the perspective of how products are designed for manufacturing and assembly, especially, we shift the focus towards the end-of-life consideration and the actual reverse process. So how products should be disassembled instead. This often provides a lot of insights, and it's good for R&D teams to be in that conversation, to understand how recyclers take care of the products, what works well and what could be improved. And our team measured the recycling rates of both products, taking into account the specific end-of-life system, the design, and the materials. The calculation is based on practical knowledge from and data from Stena recycling operation, ensuring that the estimated rates really reflect recycling in practice. Also, losses due to the joining methods, like the screws and so forth, are applied and taken into account in the calculation. Here we also wanted to share with you a little bit of insights that might come out of this assessment and specifically for the 2 products. In the analysis, we usually identify strengths that in this case led to high recycling rates, but also areas that can need improvements. And here to the right side of the slide, you see some of those insights. So joining methods always make a difference. Rivets, especially if you are connecting 2 materials with a rivet, which is of another material, it's a less good way to joining components, as it reduces the recyclability of one or the other material. So one material becomes some sort of impurity for the other material flow. Of course, there are trade-offs to consider, for instance, between making product easier to disassemble or even repaired, and making them easier to be shredded in a mechanical recycling process. That said, even if a product would meet the WE recycling targets due to its design, there are often room for improvements. And some areas to focus on when it comes to recyclability of electronics is, for instance, the printed circuit boards, which contain non-recycled plastics, and those impact recyclability. So it's good to work with a reduced mass or other opportunity there. It's good to look into surface finishes that contribute to material loss during. So when the material, the metal in this case, is recycled, the surface finish is a loss in this process. So through the smelting and recycling of the metal itself, that portion of material is lost. And then again, as Louise was mentioning before, some plastics which are used in electronics, in electronic components, and in this case, lighting, are not recyclable. So not because of they are not recyclable in theory, but because they are not recycled in the actual process and system, and switching to materials which are actually recycled could improve recycling rates. That's all from my side. So over to you, Louise.
Nice, and almost all from my side as well. Thank you, Ricardo, for the example. And to all of you listening, don't hesitate to reach out to us in case you want to know more about this and know more about your products. Now we will actually move on to the answers and questions that might have come in. So I'll stop sharing my screen here. There.
Thank you, Louise and Ricardo. I see a lot of good questions in the chat. Maybe let's start with the following. How do the additives in plastics affect recyclability? PP is good to use since it's very common, but if I need to add additives to give it a certain properties like conductivity and strength, will it still be recyclable? And then why PET plastic is recyclable when used in bottles, but not in the electronics?
I can start, and Ricardo, please feel free to fill in. Maybe starting from the end, so the PET material question, because that's quite quick, I think. PET is not used in electronics in a large extent. So in electronic products, it's a small volume plastic, you could say. So it's difficult to find to justify the business case for extracting just that material because it doesn't exist in large enough volumes, you could say. Whereas in PET bottles, of course, it's the main material. So that's the reason for that. And then the other question about the additives, I think it depends. So it depends what type of additives you are using and how big share as well. A small amount can be handled in the processes, but if it's too much, then the plastic material will not be identified as the same plastic that it belongs to, so to speak. The properties are altered too much. But then I know also that there's development going on here, so we might see more plastic types and filled plastic types in the future.
What % of the collected material normally goes to landfill? And maybe then let's talk about the hazardous waste. What is considered hazardous in the electronics?
Do you want to give it a go, Ricardo?
Yeah, I can try. The regulation really states clearly what's hazardous and what's not hazardous. So in this case, we look into the WEEE directive, for instance. And there are some materials and some components of electronic product which are listed under this term hazardous. So in this case, you have printed circuit boards, you have cables, you have a few more. And what happens there is that those type of components should be taken care of separately and sorted in specific ways. In some cases, they end up into landfill at the end of the process. In some other cases, can be incinerated. So in that case, it's energy which come out of that process. The other question was about the landfill, right? Yeah. Also in that case, the WEEE directive is setting some targets, not specific about how much material should be landfilled, but more about how much should be recycled or energy recovery in that case. And things are a bit different from type of products. Small domestic appliances have a specific target. It should be recycled up to 85% if I'm remembering correctly. And when it comes to that target, it's recycled material recycled, but also energy recovered in that target. And what's left, it's all right out of a regulatory perspective if it enters a landfill and end of life.
Maybe we can clarify a little bit about the PCBs, because it's stated, as you say, that the printed circuit boards should be taken out in a separate stream, but they are not sent to landfill or being incinerated. They are taken out to make sure to harvest the valuable materials that are in there, the copper, the gold, silver, and palladium, for example. So they are treated in a specific recycling facility for that.
Thank you. Louise, maybe you can elaborate if there are any differences in regulations between consumer electronics and B2B electronics, and if there is a difference between recycling systems, let's say in Sweden, Poland, Denmark overall.
Yeah, that's a big question. So please fill in, Ricardo, as well. I can start. It can be. It differs a bit on how they are sent to recycling, through what actor they come into the recycling facility, you could say, and they also have slightly different regulatory requirements on them. So it differs, but in practice, they all need to be taken care of. So it's not okay to leave any of those lying around in the nature or so. So we need to take care of all electrical and electronic equipment, but they have slightly different regulations covering them, you could say. Then going to the differences in different countries, I would say that the legislation is quite clear, but the WEEE directive is still a directive. Let's see if that changes. They're doing a review now, so maybe it can turn into a regulation, which in that case would make it more steered and more equal, or the same sort of solutions being used in the different countries. But still, it's a directive, and therefore the different countries can choose how they implement the legislation. It's up to each country, you could say. In terms of the recycling processes, I would say that the differences are not so big. It's more in the recycling system, so which actors are involved in collection and transport and treatment and so on, where the differences occur, I would say. But the outcome in terms of material recycling are quite similar. Maybe we have some exception, Ricardo, I don't know. Do you know any specific difference?
We still think about the business to business as business to consumer, or the by country.
Both, I think.
Yeah. But one of the main difference is the extended producer responsibility. So that the producer that sell directly to consumers should be financing an organization that takes care of the collection and then the financing of the recycling of those products, while business-to-business producers do not need to be part of that by law, or it's not mandatory, but they should anyhow promote recycling by themselves without the organization somehow. So if I'm a producer which have contact with another producer or another entity, then I need to even offer, for instance, direct collection of my products, and then I will need then to myself take contact with a recycler, like Stena Recycling, to take care of those products in that case. While in the consumer situation is more municipalities have the collection, and then the organization producer responsibility organization is taking care of the transactions between the parts.
And I see that we have 2 minutes left and still a bunch of questions, especially if we will be sharing the slides. I would like to say that the webinar is recorded and we will post the recording on our website, but we won't be sharing the slides. Probably the last question for today. As a product manufacturer, what kind of benefits can we potentially gain through recycling, given the complex and downstream chain? In practice, how do we convert this from cost adders to revenue generators?
Yeah, please fill in again, Ricardo, but I mean, it doesn't need to add costs. That's the first thing. It's all about finding different ways of doing what you always do. So it might not need to added cost, but it could, of course. But on the other aspect, I would say, is the reporting and how you will soon be required to report on recyclability and how recycled your products are, which might be interesting for customers, of course, to know, and might be something to promote and to help you get more customers, so to speak.
Probably one last question. How is the ESPR, the eco-design regulation, will be pushing further the design for recyclability practices?
Much is unknown. What we know now is what categories will be part of the ESPR, or at least for the first round. And electronics, some electronics products are part of that. So what we know at least is that recyclability and the end of life is very much a focus area, which will be looked into and will come with requirements on specific products. And of course, it's not just about that, it's also about the content of recycled materials in products, which will be looked into. So there will be requirements, and the difference with what we see now is that those requirements that we have now come from the end of life management, like the WE directive is one of those. Those requirements from the ESPR will be put directly on producers, which is a bit different perspective.
Thank you very much. I think that's all the time we have for the questions today, and we'll try to maybe answer some of them in our social media posts.
Yes, thank you all.
Thank you.